Close your eyes, Max whispers, and imagine you could walk right through your bedroom wall like a ghost. Right away, your heart races. You picture your sneakers slipping past bricks. No, don't need it. Their wild idea sparks Max's latest experiment, using quantum tunneling to break through solid walls. In his backyard lab, Max sets up a long table with a coil particle accelerator, a colorful laser pointer, and a block of polystyrene foam, painted to look like a concrete wall. He calls it Operation Goes Past. He knows real walls use atoms bound by strong forces. But at a tiny scale, individual particles can sometimes slip through barriers they shouldn't cross. That's quantum tunneling. Max divides his plan into 3 steps. Step 1. Turn his body into a giant wave of probability. In quantum physics, everything is both a particle and a wave. Electrons in your computer chip tunnel through thin barriers all the time. But for a person, that wave would be incredibly small and tight. Max sketches a graph showing a wave function that shrinks quickly inside a big wall. Its numbers look scary. A 1.5 meter tall kid has a de Broglie wavelength, almost 0 way tinier than an atom. Undeterred, Max moves to step 2. Lower the energy barrier. He imagines blasting the wall with a super powerful laser, hitting it hot enough to shake its atoms loose. If the barrier gets shaky, maybe his wave can wiggle through. He clicks the laser pointer at the foam block, which glows red under the light. In real life, he mutters, hitting a brick makes it stronger. But on this love, he laughs at the mistake. Still, he notes that in stars, quantum tunneling helps hydrogen nuclei fuse, even though they repel each other massively. Heat alone can't break the wall either. Step 3. Add more energy to his wave. The more momentum he has, the longer his wavelength gets. Right? Max imagines riding a rocket into his tunnel chamber, zipping through at top speed. In his notebook, he writes E equals p squared over 2m. He sees that boosting energy actually shrinks the wave, making tunneling even less likely. His smile fades. He calculates the chance. Something like e to the minus 10,000 trillion. That is 0 for all practical purposes. Max sits back and grins. He didn't break through any real brick wall today, but his thought experiment showed why quantum tunneling works for tiny particles and never for big objects like us. He learns how energy, mass, and barrier weak all dance together in the math. He also learns that in semiconductors, tunneling enables tiny transistors and diodes, the heart of every smartphone. Max flicks off the laser pointer and pushes the foam block aside. Maybe I can't walk through walls, he admits, but I can walk into the world of science. He dreams of someday using these ideas to build quantum computers or new energy devices. And who knows, the more he studies, the more real magic he might create. No supernatural power needed.